Hello, welcome to this lecture on JavaScript. In this lecture, we're going to cover the keyword, object-oriented programming, JavaScript inheritance, asynchronous JavaScript, Ajax, the fetch API, and TypeScript. So, JavaScript, why do I care? This is the scripting language that forms the basis of JavaScript. What do I need? VS Code, Mozilla Developer Documentation, and W3 Schools. How do I do it? This example shows an operation being performed. Here we can see that we have multiplication, and we're using an arrow function. Take the example shown above and change it to an addition operation. Here's the solution. We modify this arrow operation to take an x plus y, and then we get the expected output. So, JavaScript arrow functions. With arrow functions, you don't have to type the function keyword, the return keyword, or the curly brackets. Arrow functions are not supported by Internet Explorer 11 or earlier. This demonstration shows you how to use an arrow function. What if, what about? What new features were introduced in ES6 that were not available in other versions of ES5 and below? So let and const. Let allows you to assign a variable that is modifiable, whereas const is read-only. So here we have let and const. Let and const can't touch the global scope from function or block scope. And var can't touch the global scope from function scope, but can from block scope. You can see the var in a window object. With const and let const and arrow functions are not hoisted. However, var functions are. We can also look at const and reference types. So arrow functions are still just functions. There are a few differences though. The binding is the primary functional difference. There's no parameters. If we just have one parameter, we can omit all of these curly braces and we can return anything after the arrow indicator. That's the process of creating an arrow function. Okay, so we'll look at an arrow function here. Arrow function expressions. An arrow function is a compact alternative to traditional function expressions, but is limited and can't be used in all situations. We'll look at let. Here's an example of let. So we have var is equal to 10, and then here we can reassign the variable to 2. Let's take a look at const. The const keyword allows you to declare a const JavaScript variable with a constant value. Constants are similar to let variables, except that the value cannot be changed. Here we have x, and we're setting it to const. There's other operations that can be performed, right? Rest is a parameter passed into a function definition that can accept any number of parameters. The parameters are treated as an array of all parameters passed in. Then we also have spread. Spread is an argument passed into a function call. Spread allows us to pass in arrays that may be too large to normally process. You can pass in arrays that are too big. You'll just get a bunch of undefined stack at the end. An object destructuring is mostly a useful shorthand, but much cleaner. We can destructure objects in our parameters to pull out the values we need. So for example, a function that is a greeting, right? We can specify greeting, parenthesis, bracket, bracket, name, age. We'll take a look at that here. So destructuring assignment. Destructuring assignment syntax is a JavaScript expression that makes it possible to unpack values. So here's an example of destructuring. We can run this. Here's another example. So this goes through the example of destructuring. Now we'll look at this keyword. What is this? This refers to the object. It's a self-reference to the object. This is the object executing the current function or method. The new keyword is a way for us to instantiate a new object, right? The new keyword ensures that this always points to the object in which you create. We'll see this in more action when we cover object-oriented programming. And then call can be used to call a method or function with a specified bound. The first parameter is the object to bind this to. Apply is just like the call, except instead of passing arguments in a separated comma, you pass an array. So these resources on the slide are available, and you can use these to show yourself what these methods actually do. So why do I care? This refers to an object, right? It's a way to reference that object. What do I need? VS Code, Mozilla Developer Documentation, and W3 Schools. Take the example shown above and change it to print out the sum of 42 and 40. Take the example above and change it to print out the sum of 42 and 20. We can see that we're using this property here. The method that we're calling is func, and the output of this method is the expected output of 42. Modify this to show the sum of 42 and 20. Here's the solution. We just modify this function here where we're using the self-reference to the property, which is the value of 42, and we're adding 20, and the output of the function is 62. Why do we use this keyword? The most common use case of this is to eliminate the confusion between class attributes and parameters with the same name, because class attribute is shadowed by a method or constructor parameter. Now we'll go over JavaScript object-oriented programming. Object-oriented programming is one of many popular programming paradigms and is probably the most popular. ES5 syntax is the old means of doing it. We don't really use it so much. Classes always begin with a capital letter for formatting, and we use the class keyword if we want to specify a class. We also have what's referred to as a constructor. So if you're familiar with a matrix, when they load the matrix, right, the constructor constructs the reality that they're experiencing. That's a way for us to instantiate this class that we're talking about. A class is a representation of an object, of a real-world entity. Instantiation is the creation of this new object. So static methods don't need an instantiated object to call the methods. Why do I care? We can use object-oriented programming to simulate real-world objects. What do I need? VS Code, Mozilla Developer Documentation, and FreeCodeCamp. Take the example shown above and add a new property to show the model of the car. Here we have an example of inheritance, so we have the class car. And here we have the class model, which extends the class car. And we're calling show. So your goal is to take this example and add a new property to show the model of the car. See the solution above? Here we have the class car. We have the car name, this.model. And then we have model extends car, and this.model equals mod. So now we're passing in the model, and we pass in Ford Mustang. And then we have mycar.show, which shows the result. Now we'll go over object-oriented programming. So object-oriented programming is one of many popular programming paradigms. It's probably the most popular. And ES5 syntax is the old means of doing it. We don't really use it so much. Classes begin with a capital letter, and we use the class keyword. And we have a constructor function whenever we create an object. This constructor function will create this new object, and this constructor acts like a way for us to create real-world entities. So if you think about the matrix, you know how they load up the whole entire simulation? That's the constructor for our objects here. We pass in the parameters, and then we create something. Instantiation is the process of creating this new object. So, why do I care? We can use object-oriented programming to simulate real-world objects. What do I need? VS Code, Mozilla Developer Documentation, Free Code Camp. How do I do it? Take this example and add a new property to show the style of the car. So how do I do it? Here we have the model, right? It takes in a brand, mod, which is the model, and then it calls the super, which is the super constructor, which is the object that we're inheriting from, which is the car, and we're passing in the brand. So modify this to use this to add a style to the car. Give it a shot. Here's the solution. So we've added here's the solution. So we added the style to the constructor. So now the car has a style property associated with it. It is the style here. Now we have the model, which takes in brand, mod, and style, and the super constructor calls brand and style. And when we call show, it will show us the model, which contains the brand and the style here. Okay. What about? Why is object-oriented programming an important concept? Object-oriented programming is famous because it implements real-world entities like objects and hiding and inheritance and all these other wonderful concepts. What is JavaScript inheritance? Inheritance is when one class is a subclass of another. Ford and Chevy could be subclasses of a car. We use the extends keyword to make these connections. We can use the super in our constructor to save some time. We can call static methods from the parent class from static methods in our subclass with the super.method. Why do I care? Inheritance allows you to reuse properties and methods of an existing class when you create a new class. What do I need? VS Code, Mozilla Developer Documentation, and W3 Schools. What if, what about? When would I use inheritance? The main reason for using inheritance is not as a form of composition, it is so you can get polymorphic behavior, the ability to inherit from different objects, right? We have a base class here called a car, and from that we inherit all the properties from car in a model. We could have multiple inheritance. We could have a type of vehicle which inherits from an airplane class and a train class and a bus class. That's a polymorphic object, right? It has a vehicle which inherits tons of things. Okay, so let's look at asynchronous JavaScript. What is asynchronous JavaScript? Synchronous programming is what we've been doing so far. JavaScript reads and executes the application from top to bottom, left to right. Asynchronous programming is the opposite of this. It is a cornerstone of how Node.js works, so it'll be important moving forward. Next, understanding this, async is probably the second most difficult thing about JavaScript. We've already seen callbacks a little bit, but we'll take a deeper dive here. Right, callback hell is when you have too many callbacks being chained together. To simplify callback hell, ES6 introduced promises. Promises are kind of like functions that are asynchronous. A promise constructor takes in two parameters. The first is a resolve and the second is reject. When you call resolve, that activates the .then, and reject calls the .catch side. We can chain these promises and returning promises from other functions. We can also call promise.all. Async await is a newer way of consuming promises. It replaces .then and .catch. Okay, so you'll be consuming promises with .then, .catch, and or async await syntax. Let's take a quick look at promises real quick. So, the promise object represents the eventual completion or failure of an asynchronous operation and its resulting value. To learn about the way promises work or how you can use them, you can read the using promises first. A promise is a proxy for a value not necessarily known. When the promise is created, it allows you to associate handlers with asynchronous actions, eventual success or failure reason. This lets asynchronous methods return values like synchronous methods instead of immediately returning the final value. The asynchronous method returns a promise to supply the value at some point. A promise is in one of these states: pending, which is the initial state; fulfilled, meaning the operation was completed; rejected, meaning the operation failed. A pending promise can either be fulfilled with a value or rejected with a reason. So here's an interaction that we can look at. So here's the promise. We go to fulfill, we go to reject. This gives us our asynchronous actions. This gives us our .then, as we said. And then we have the return of the promise, which goes to .then and .catch. So why do I care? Asynchronous programming is a technique that enables your program to start potentially long-running tasks, and then rather than having to wait until that task is finished, to be able to continue to be responsive to other events, that task can keep running. Once the task is completed, your program is presented with the result. This means no waiting. So people want this sort of asynchronous behavior. That way they don't have to wait for the page to load. So, what do I need? VS Code, Mozilla Developer documentation. How do I do it? Take the example shown and modify it to take additional parameters. Here we have a callback being passed in. This callback function is my callback. So my callback So how do I do it? Here we have an example. We want to take this, we want to add an additional parameter to this example. My calculator takes in two function arguments here, num1, num2, and then a callback. And here we're adding these numbers together to get a sum, and then we call our callback, which takes the sum. Now this is just a callback, right? So when we call my calculator takes these two parameters here and this third one, which is the callback. And you can see that we're passing in the function myDisplayer. Run this example and modify it so that we can take the additional sum of another number. So not just two parameters, we want to have three. So here's the solution. We just add an additional parameter here, and if we call that method, it should print out the three terms as we saw in the example before. This time it's going to take the sum of all three of these terms rather than just two numbers. What about? When should I use asynchronous JavaScript? Asynchronous loops are necessary when there is a large number of iterations involved or when the operations within the loop are complex. But for simple tasks like iterating through a small array, there's no reason to overcomplicate things by using complex recursive functions. Now I'll go over Ajax. Ajax requests can be useful for using APIs whether we define them or another developer did. We haven't learned how to build our own APIs yet, so let's see how we can use someone else's API. We can go to this example here. So we can use HTTP GET to retrieve what you want, right? This is a read method, and that can return JSON. The results returned as JSON can be processed by JavaScript, right? So here's an example, right? We have our JSON, and this type of value is returned. When it's returned, it's a successful request. So we can change the name of main character by passing in these parameters. These parameters are request parameters. When we make that GET request, it goes to the URL, and we're passing in these parameters John and Doe, and it's processing that request. And once it does that, those go to the server. Okay. So get methods, get some data. Other methods, we have post, which will write data, put, which updates the data, and delete, which removes data. The important HTTP status codes to understand are 200, 403, 404, and 500. 200s are good. 400s are bad requests. 403s are forbidden. 404 means it's not found, and 500 is a server error. The other thing to understand is CORS. So CORS stands for Cross-Origin Resource Sharing. It could be an authentication problem, an unreachable address, or more commonly, the latter.
Greetings friends, welcome to A Shot of Code. Today we're talking about CORS, which is Cross-Origin Resource Sharing. Now this is a
We'll watch this YouTube video here which will explain CORS.
Feature that actually relaxes the security of your website or API. By default, the same origin policy applies in browsers, all the browsers, so you can only call from your origin back to your web server. So this, that's in place to kind of help mitigate cross-site scripting attacks. Now, there are cases where you want to relax this, but you don't want to be able to let everybody in, and that's where CORS helps us. It can specify certain origins that are allowed to access the API. So if you've got a subdomain or particular third-party websites, you can let in just those rather than everyone. And it does this by returning a CORS header in the response headers, and the browsers, it's only the browsers that implement this, by the way. If you try and access an API from the command line, there's no CORS in place. You can access it, so it's just a browser security feature. Same origin doesn't apply when you run fetch from a Node app. You can get to the data. Right, so let's jump in and have a look at an example. So I've got a couple of API sites here. We've got a Star Wars one here, and let me just go back to the network here and clear that down. So if I was going to make a call here, now, so because I'm on the Star Wars site, I'm on the same origin, so I can call this API without any problems at all. If we look at the network request, our response, we're getting a 200 response. The response headers here don't specify, they don't even need to specify any CORS headers because the browser is going to let you see this information anyway. If we were on a different origin, the browser would only let you see it if that CORS header, it's called access control allow origins, only if that is present and it's got your origin on it. So we've got another one here, Chuck Norris one. We can make a call to Chuck Norris, and if we look at that one, it's very similar. Nothing required there. So let's, that's BAU, but let's now create a site that's not from the origin of these sites and try and call into it then. So if I open up code, and we'll just create an index.html, and we'll put some boilerplate there, and we'll just create a script, and we're going to call fetch in here, and we're going to try and fetch, just make this a bit bigger, it'll just be bigger on there as well, and even this one we'll just make a bit bigger. So let's have a look. What call did I make? Here's the call I made from the website. So let's try and call that. Now it's going to be a get, so I just need to specify that as a get. And then we will get some JSON back. So we'll turn our response into JSON. And that will then give us the data. And we're just going to console log that out like so. Just try to make that a little bit nicer. Okay, so Made an error here, return JSON. It doesn't like that because, why don't you like that? You need to do return, really. I'll probably just accept that. Yeah, there's an implicit return on that one. That's fine. Okay, let's open this up in live server and make it a bit bigger. And if we open up the dev tools in here, we can see what's being called. So what we're getting back in this case, if I just refresh it again, we get back R2D2. So that is fine. And if we look in the network, we can see our call here, our fetch call. And we, compared to when the first two that we did, we're now seeing a different response header, the access control allow origin. So the Star Wars API website has basically put a star, so it's allowing anyone to access this API. So its cause implementation has added this in the response, and our browser, because it sees this, is going to let us see the data. If that wasn't there...
So that wildcard means that anyone can make this request. I encourage you to watch the rest of this YouTube video to understand how CORS works. So, Ajax. Why do I care? Ajax can be used for interactive communication with an XML file. XML, Extensible Markup Language, is a markup language similar to HTML, but without predefined tags to use. With XML, you create your own tags instead. So, let's try an example. What do I need? VS Code and W3C documentation. How do I do it? Clone the Ajax module down and add a get method to return a set of flashcards from the server. So we want to return a set of flashcards from the server. Take the code that's there, research, and modify it, and figure out how to add a get method that can return the cards from the route /get card. We want to be able to return a get request. So /card is the request that you're trying to make. Figure out how you can do that. Give it a shot here. Here's the solution. We have a function getCard. We create a new XML HTTP request object, which is the most important part about web development. Understanding this is the fundamental understanding of how to make requests, right? So this is very, very important. Here we're calling xhr.open get, and we're going to the URL card, and then we're selecting a category. And then we have the onload function here. So this onload function will process the response from the request, and it'll log out the card, and it'll show us all these other details. The HTML will get updated. It gets called on xhr.send. What if, what about? What is the point of using Ajax and XML? Ajax applications might use XML to transport data, but it is equally common to transport data as plain text or JSON text. Ajax allows web pages to be updated asynchronously by changing data with a web server behind the scenes. This figure explains Ajax. Here we have an event that's triggered on a web page. An XML HTTP request object is formed and sent to the server. The server processes it and creates a response. The response is sent back to the client, and the processed data is returned to the page. We process the data with JavaScript. So, here's a quick rundown of Ajax. We have these methods: xhr.open, xhr.onReadyStateChange, xhr.onload, xhr.onProgress, xhr.onAir, xhr.send, and then this.response text, right? So we replace the method get, post, put, or delete as the first parameter. And then the URL is the location, that's the second. This should be set to true. And then false is synchronous, however you get a warning as it is being deprecated. Ready state change is the old way of doing it. And here are the values. 0 is unsent, 1 is open, 2 is headers received, 3 is loading, 4 is done. OnLoad replaces the ready state change and only executes the function once the request is completed. So the basic syntax for this would be let xhr equal a new XML HTTP request object, and then we call xhr.open, and then we pass in our method, which would be get, our location, the URL, and then either true or false. And then after that, we call xhr.onReadyStateChange, set it equal to a function, and then if the ready state is equal to 4, then we know that we've had a successful response, right? The values for that are going to be 0 is unsent, 1 is open, 2 is headers received, 3 is loading, and 4 is done. Now look at the fetch API. So with the fetch API, you must have a .then response, which takes the arrow function and then turns the response into JSON. So before you do anything else, this is necessary. The second parameter is the init object. There are a lot of different options we can pass in here. So the method would be post, get, put, and delete, and the mode would be cores or no cores or same origin. And then the headers are the headers that you can set. So why do I care? The Fetch API provides an interface for fetching resources, including across the network. What do I need? VS Code and W3C documentation. How do I do it? Take the example shown above and add the user agent to the header request. Give it a shot. So here's the solution. We've added a new set of headers and we specify the user agent, and we're calling this method. So what if, what about? What is the point of using Ajax in XML? What is the point of using fetch? The Fetch API provides a JavaScript interface for accessing and manipulating parts of the HTTP pipeline, such as requests and responses. It also provides a global fetch method that provides an easy, logical way to fetch resources asynchronously across the network. So now we'll talk about try-catch. Try-catch exists in most programming languages. Try blocks try to execute a block of code to look for errors. It only looks for runtime errors, not parse errors. Catch blocks are used to handle the errors that may have occurred in the try block. You cannot have a try without a catch, and you cannot have a catch without a try. The error is a parameter. We have an error object, and an error.message, and an error.stack. So that stops execution of the try block on an error. So if an error is thrown, we catch it in the catch block. Throw can be used to throw errors. If you encounter an error, you must catch it, and then the application will end. We don't need to have a try-catch block to throw an error. You can easily just have a try-catch block to throw an error. We don't need it. You can just throw an error message. Finally, blocks can be written to have code that is always executed regardless of the outcomes of the try-catch block. So, why do I care? The try statement is used on a block of code that is most likely to cause an exception. The catch statement catches the exception that was thrown in the try statement. So what do I need? VS Code, W3 docs. How do I do it? Take the example shown above and add a throws exception. Now you try it. Here's an example. So in this case, we are throwing an exception and we're logging out the error. What if, what about? Should I use a try-catch statement in all of my code? Why or why not? You should only use a try-catch for exceptions. Then you can actually use these for actually stopping code, right? So you only want to use try-catch for exceptions that you can actually do something about. Furthermore, you should hardly ever catch the base system.exception class, but rather prefer to catch the more specific derived exception classes you can handle. So let's go for TypeScript. What is TypeScript? TypeScript is a superset of JavaScript, which primarily provides optional static typing, classes, and interfaces. One of the big benefits is to enable IDEs to provide a richer environment for spotting common errors as you type the code. TypeScript doesn't run in the browser. The code written in TypeScript is compiled to JavaScript, which then runs in the browser. TypeScript is open source. It was designed by Anders Hallsberg, the lead architect of C# and Microsoft. Here are a couple features. The code is written, so it's compiled, there's types, it's a typed language. So it's a superset of JavaScript and it compiles to vanilla JavaScript. We can look at the different types. We have a string. So the string object lets you work with a set of characters. It wraps the string primitive data with a number of helper methods. Here's an example of creating a string type. We have the number. So TypeScript, like JavaScript, supports numeric values as number objects. A number object converts numeric literals to an instance of the class number. Here's an example. We also have the type of Boolean. So here's an example, TypeScript Boolean, right? The Boolean object is different from the lowercase Boolean object. The uppercase Boolean is an object type, whereas the lowercase Boolean is a primitive type. And we have array. So TypeScript has specific syntax for typing arrays. Here we're setting the array and we're adding Dylan to the array. Any is a type that disables type checking and effectively allows all types to be used. So the example below does not use any and will throw an error. This example will use any and it won't throw an error. So why do I care? It is a superset of JavaScript and adds additional syntax to JavaScript. What do I need? VS Code, W3C documentation, and then the TypeScript online compiler. How do I do it? Take the example shown above and calculate the sum of these numbers and concatenate all of the strings, right? We want to take this and concatenate all the strings and show the sum of the numbers. Now you try it. Here's the solution. So we're going through all the values and we're summing up all the numbers and concatenating all the strings. What if, what about? What are the benefits of using TypeScript? Well, JavaScript is a programming language that is developed by ECMAScript. JavaScript is a programming language that is developed by ECMA's Technical Committee 39, which is a group of people composed of many different stakeholders. TC39 is a committee hosted by ECMA, and internal standards of, What if, what about? What are the benefits of using TypeScript? JavaScript is a programming language that is developed by ECMA's Technical Committee 39, which is a group of people composed of many different stakeholders. TC39 is a committee hosted by ECMA, an internal standards organization, and JavaScript has many different implementations by many different vendors, such as Google, Microsoft, and Oracle. The goal of JavaScript is to be lingua franca on the web. TypeScript is a superset of the JavaScript language that has a single open source compiler and is developed mainly by a single vendor, Microsoft. The goal of TypeScript is to help catch mistakes early through a type system and make JavaScript development more efficient. So here are a couple other types. We have void. This type void can be used to indicate a function that doesn't return any value. We have null. tuple, which we saw, enum, and then we also have generics. All right. This allows us to, use types, which leads to automated compiling. We can watch multiple files. There's type erasure and error behavior. We can define a string, a number, a boolean, any, or an array, or even a tuple. We can also define void types, right? We can define these different parameter types. We can pass in the optional parameter, and then we have the void return type, and we also have union typing. The interface is a way for us to create an object that can interface with another object. We can take a look at this. So, type aliases allow for defining types with a custom name. Type aliases can be used for primitives like string or more complex types such as objects and arrays. Then we also have interfaces. Interfaces are similar to type aliases, except they only apply to object types. So here's an example of an interface. We can look at encapsulation. So what is encapsulation? Encapsulation is the packing of data and functions into one component, for example, a class, and then controlling access to that component to make a black box out of the object. Because of this, a user that's class only needs to know the details, that is the data and functions exposed outside the class, and it's not hidden from the implementation. We also have the concept of getters and setters. So getters and setters allow you to get object properties off the class. Setters allow you to set properties on the class. And then we have access modifiers. Public. Public can be accessed anywhere without restrictions, and then private ensures that class members are visible only to that class and are not accessible outside the containing class. Then we have protected. Protected is similar to the private access modifier, except that protected members can be accessed through using their deriving classes. Then we have the concept of read-only. So, TypeScript read-only. TypeScript read-only includes the read-only keyword. That property makes read-only in the class on a type or interface. The prefix read-only is used to make that property as read-only. Read-only members can be accessed outside the class, but their value cannot be changed. Since read-only members cannot be changed outside the class, they either need to be initialized at declaration or initialized inside the class constructor. So, here is an example. Here we have read-only class properties. In the above example, we have the employee class with two properties, employee name and employee code. Since employee code is read-only, it can be initialized at the time of declaration in the constructor. So why do I care? These are used to unpack data and functions into one component and allows you to determine how the data and functions should be accessed. For example, read-only. What do I need? VS Code, W3C documentation, and the TypeScript online compiler. How do I do it? Take the example above and use it to create a character with a damage setting, then log the object to the console. This is a continuation of the example here. Now give it a shot. So, here's a solution. We create that new character with a name, and we set the character name to Elon, and then we console out that name. All right. What are the benefits of using TypeScript? So TypeScript allows us to use typed variables. This is very beneficial because we know what we're dealing with. It's not just regular JavaScript where all the variables are, just either let or const. This actually has specific meaning when we create a variable. So, TypeScript modules. What are TypeScript modules? A module refers to a set of standardized parts or independent units that can be used to construct a more complex structure. TypeScript modules provide a way to organize the code for better use. So here's an example. The interface iShowDetails. We're exporting the interface iShowDetails, and then here's an example of importing the iShowDetails. Yep. So we can see that we're exporting class student, which implements the showDetails, iShowDetails, and then we call display, which logs out the student details. So the import keyword, right? We can import the thing from the relative path. The import keyword is used to declare the module in another file. Why do I care? Okay, we'll talk about polymorphism. Polymorphism allows you to perform a single action in different forms. Example, using a method named withdraw to withdraw from a bank account, digitally or physically. What do I need? VS Code, W3C documentation, and the TypeScript online compiler. How do I do it? Take the example above and use it to call orc attack and orc talk. Give it a shot. Here's the solution. We declare our orc as a new object, and then we call orc.talk and orc.attack. Run this code, make sure that it works in the compiler, verify your results. What if, what about? When should I use polymorphism? When multiple classes inherit from a parent and override the same functionality, the result is polymorphism. Each of those child classes now implements a property or method, but they may have different ways of doing it in their own implementation. So here's an example of polymorphism. We have animal, which can be a cat or a dog, right? And those inherit from that. Or we have account, which can be checking or savings, and that's inherited, right? Polymorphism means many forms. Polymorphism means the ability to take more than one form. It's the ability to use an operator or function in different ways. Polymorphism gives different meanings or functions to the operator or functions. Poly, referring to many, signifies many uses of these operators and functions. A single function usage or an operator function can be used in many ways. That's polymorphism. This concludes this lecture on JavaScript. So in this we covered this keyword, object-oriented programming, inheritance, JavaScript, Ajax, fetch, and TypeScript.